Can you guess what we're going to learn about today? That's right, it's the mean value theorem. Now, the mean value theorem is one of those other theorems you learn at the beginning of calculus and you don't really pay much mind to because you're not doing any, quote, real math. So you think you're not going to need to know it, and then it shows up on a multiple choice question or a free response question, and then you wish you did know it. So today we're going to go over what the mean value theorem is. Now, first, let's talk about the function that we are going to look at the mean value theorem for. So f of x must be continuous on a closed interval. So f of x must be continuous on the closed interval, we'll say from a to b, right? Further, f of x must be differentiable. F of x must be differentiable, we'll call this diff, on the open interval a to b, all right? So if we meet those two requirements, then we can say that there exists some point c such that a is less than c and c is less than b, so meaning that c is on that interval from a to b. There exists some point c such that the derivative, okay, so f prime of c is going to be equal to f of b minus f of a over b minus a. Now, what exactly does this mean? Now, does anybody recognize this formula right here, f of b minus f of a over b minus a? That's just the slope. That's the formula for slope, right? y2 minus y1 over x2 minus x1. So we're saying f prime of c is equal to the slope of the straight line from a to b, right? Okay, that makes a little bit of sense. Now, what exactly is f prime of c? Now, remember, the derivative of a function at some point will give us the slope at that point. So what we're saying is that the slope at the point c is going to be equal to the slope over the entire interval from a to b. All right. Now let's look at a graph so we can picture this. All right. So let's draw. This is a y-axis and this is an x-axis. All right. We'll label these y, x. And, I don't know, let's say our function looks a little bit like this, right? Say our function is like here, let's throw a curve in it, blah, all right? And it ends right there. So this right here is point A, and this right here is point B. Now, if we drew a straight line from A to B, right? So if we drew a straight line kind of like this, hopefully this is straight. That was pretty straight. That's what's it called? We can find the slope of that line by doing this equation right here, f of b minus f of a over b minus a. And what we're saying is there exists some point c on our interval where the line tangent to the point c is going to be is going to have the similar slope, with the exact same slope, to the slope of this blue line right here. Now, what does it mean when slopes are exactly the same? It means the lines are going to be parallel. So there are a couple points on this function where the slope might be a parallel line, right? And we don't have actual numbers here, so we can't test for sure, but let's visualize this. Say right here, say that this was our point C here. Let's use a different color. Say that purple was our point C, such that the derivative of that at that point is equal to slope over the whole interval. Then that means the equation of the tangent line would look a little bit, I'm drawing it kind of rough, would look a little bit like that. You see how it's parallel to the blue line, or it might exist somewhere else. Say right here, let's say right here was our point C. And again, we can't test this because we don't have actual numbers. If we did, we could, and we'd find the slope at that point. But let's just say that it is right here. Then we would have a parallel line running right next to this blue line, or turquoise, whatever you want to call it, right? So that's a little visualization of the mean value theorem. So that's all that is for today. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.